We all remember learning about squares and circles back in school. But what about all the messy, complicated shapes we actually see in the real world? Well, it turns out geometry has some incredible secrets for measuring just about anything. And today, we are going to unlock them. Okay, let's just dive right in. How in the world do you go from measuring something simple and predictable, like the square on the left, to finding the area of that, I don't know, that spiky, irregular blob on the right? It looks like it would take forever, doesn't it? Well, stick with me, because the solution is way more elegant than you might think. All right, before we get to the really cool stuff, let's do a super quick refresh on two concepts that are, the building blocks for everything else we're going to talk about: perimeter and area. So first up is perimeter. It's really simple. It's just the total distance around the outside of a shape. Think about it like you're building a fence around your yard or wrapping a gift with a ribbon. That length you need, that's the perimeter. For any shape with straight sides, you just add up the length of every single side. Boom, done. And then, of course, you've got area. This is all about the amount of space inside the shape. Like, how much paint do you need to cover a wall? Or how much grass seed do you need for a new lawn? That's area. It's the surface something covers. For a nice friendly shape like a square, the formulas are an absolute breeze. To get the area, you just multiply one side by itself, side squared. And for the perimeter, just take the side length and multiply by 4. Easy peasy, right? But what happens when you're dealing with a shape that's not a perfect square or a perfect triangle? Well, this is where the real fun starts. So when you're staring down a weird, complex shape, there's a really powerful strategy we can use. It's called divide and conquer. The first thing you've got to do is figure out if there are any missing side lengths. Once you have all the outside edges, you can just add them all up to get the perimeter. Now for the area, that's the cool part. We just slice the shape up into simpler pieces, like rectangles. We find the area for each of those little guys, and then we just add them all together for the grand total. It's a fantastic way to turn one tricky problem into a few really simple ones. Breaking shapes apart is a great trick, but what if there was a hidden formula that did the exact opposite? One that unites a whole family of shapes that look totally different, all with a single, beautiful equation. Take a look at these for a second. We've got a triangle, a square, a circle, a hexagon. I mean, they seem so different from each other, but they all share one very special property. Any ideas what it could be? The secret is that you can fit a circle perfectly inside every single one of these shapes, so that it just barely touches every side. This is called an inscribed circle, or an incircle, and its radius is the key to everything. For any old polygon, we call this the in radius. Now for regular polygons, like that hexagon, it has a special name, the apotheme. But it's the exact same idea. It's just a line from the very center to the midpoint of a side. So you got to remember this term, the in radius, which we'll just call R. This one little measurement is the secret key that unlocks a hidden connection between all these different shapes. And here it is. This is the secret. It's just brilliantly simple. For any shape that has an in radius, this amazing relationship is always true. The area divided by the perimeter always equals the in radius divided by 2. It's like the one formula to rule them all. And the crazy thing is, the math works out perfectly every single time. Look at this table. It doesn't matter if it's a square, a circle, or any regular polygon. When you plug in the formulas for area and perimeter, it always simplifies down to R over 2. Now, what's really cool is why this works. You can imagine any of these shapes being made up of a bunch of tiny little triangles, with the in radius R as their height. This formula is basically just averaging out the area of all those little triangles. It's just an incredibly elegant piece of math. Okay, so we have this amazing universal formula. But what about those really messy, irregular shapes we saw at the beginning? The ones that don't have an in radius? Surely there's no easy way to measure those. Or is there? Our first shortcut is for any shape you can draw on a grid. And honestly, it feels like magic. It's called Pick's theorem, and it lets you find the exact area of a shape just by counting dots. Seriously. No rulers, no protractors, just simple counting. So here's how it works. The area equals the number of dots on the inside, I, plus half the number of dots on the boundary, B, and then you subtract 1. So let's try it with this shape right here. Okay, we count 7 dots on the inside, and there are 8 dots right on the boundary line. So that's 7 plus half of 8, which is 4. That gets us to 11. Then we subtract 1, and we get a perfect area of 10. It's really that simple. But what if you don't have a grid? What if all you know are the x, y coordinates of each corner? Well, there's another amazing tool called the shoelace formula. Now, it looks a bit more involved, but the idea is pretty straightforward. You list out all the coordinates in order, then you start cross-multiplying them in a special pattern. First downwards and then upwards, kind of like you're lacing up a shoe. You add up all the down products, add up all the up products, find the difference between those two sums, and then just divide by 2. It's a step-by-step process that nails the exact area every time, no matter how wild the shape is. So with all these incredible tools, it really seems like we can measure just about anything, right? But geometry has one last surprise up its sleeve, and it comes from a shape that looks deceptively simple. Meet the ellipse. Finding its area is surprisingly easy. It's just pi times a times b. Simple, elegant. But what about its perimeter, the distance around it? You'd think that would be easy too, wouldn't you? Wrong. There is no simple formula to calculate the perimeter of an ellipse. Not a single one. It is one of the great paradoxes in all of geometry. And I am not exaggerating here. The website Math is Fun puts it perfectly. Strangely, the perimeter of an ellipse is very difficult to calculate. To even get close, you need to use complex approximations or something called infinite series, a level of math that just seems way too powerful for such a simple-looking shape. To even begin to solve problems like the ellipse's perimeter, you have to enter a whole new world, the world of calculus. You need powerful techniques like integration, which you can see here, to find the answer. It's just a fantastic reminder that even in the most familiar shapes, there are always deeper, more complex layers waiting to be discovered. So geometry is this amazing world filled with elegance, surprising shortcuts, and really deep paradoxes. From a basic square to a complex polygon, there's always some hidden pattern to be found. It just goes to show you, if you look closely enough, the world around us is just full of these mathematical secrets, which leaves just one question. What other hidden patterns are just waiting to be discovered?